Hi everyone, it's Mrs. Summer here to discuss isotopes. In this lesson, you will be able to describe isotopes, calculate the number of neutrons for each isotope, and write and read isotope notation. If you remember, the atomic number is equal to the number of protons. In a neutral atom, the number of protons is equal to the number of electrons, but only in a neutral atom. To determine the number of a neutron, subtract the atomic number from the mass number, or the atomic mass. The mass number, otherwise known as atomic mass, is the big number. The atomic number is the smaller number. And that gives you the number of neutrons. In this lesson, we're going to focus only on the nucleus, which contains the protons and the neutrons. Isotopes, there are different versions of an atom. Isotopes have the same number of protons, because if you change the number of protons, you change the identity of the element. So it's got the same number of protons, but an isotope has different number of neutrons. So isotopes of atoms are atoms of an element with different atomic masses. So different atomic masses. The atomic number is the same, but the bigger number, or the atomic mass number, or the mass unit, is different. So in this example, lithium, there's lithium-6, lithium-7, and lithium-8. All three of these have 3 protons. The difference is lithium-6 has 3 neutrons, lithium-7 has 4 neutrons, and lithium-8 has 5 neutrons. So why are isotopes important? Certain isotopes are radioactive because of their unstable nucleus. So they have some pretty interesting applications. You can use them in food preservation, archaeological dating of artifacts, so carbon dating for different, knowing how old certain fossils are and everything. And then medical imaging, where they use radioactive isotopes in order to see the images more clearly, and then also radiation treatment to kill tumors. If you remember back in Math 1, when we talked about exponential growth and decay, in order to date different isotopes or different items like this wood, in order to date it, they used exponential decay of the carbon-14 isotope. So how do we represent isotopes? So there's 2 main ways. The first way is the mass number notation. So write the element name with the mass number after it. So lithium-6 would be when there were 3 neutrons, lithium-7 for 4 neutrons, and lithium-8 for 8 neutrons. The next way is isotope notation. Write the element symbol with the mass, and then the number and atomic number. Sorry, that was very confusing. So first you write the atomic symbol. Then on top, you're going to write the mass number, and then on the bottom, you're going to write the atomic mass number is written on top, and it's the larger number, and the atomic number is on the bottom, which is the smaller number. If you notice, all 3 of these isotopes have the same atomic number because there's all still lithium, but what changes is the atomic mass number. So you try writing isotope symbols. So for number 1, carbon with a mass of 14 using the mass number notation. So mass number notation. Uranium with a mass of 235 using isotope notation. And then number 3, identify which number is the mass and which is the atomic number on this example. So carbon with a mass of 14 using mass number notation. Oops, wrong utensil. would be carbon and then dash 14. So for mass number notation, remember you write the entire element name, dash, and then the mass, which is 14. Uranium with a mass of 235 using isotope notation. Uranium is U. The mass is 235. So the atomic mass of uranium is 235 on this one. The atomic number is 92. Yes, 92. And then number 3, identify which number is the mass and which is the atomic number. 13 is the atomic mass. And then 6 is the atomic number. In this example, calculate the protons, neutrons, and electrons for the 3 different isotopes of lithium. So the atomic number is 3 for all of them. The atomic mass is 6 for lithium 6, 7 for lithium 7, and 8 for lithium 8. The number of protons in all of them is 3, and the number of electrons in all of them is 3. The only difference is that the number of neutrons has changed. So to figure out for lithium 6 the number of neutrons, we're going to do 6 minus 3, which is 3 neutrons. Lithium 7, we're going to do 7 minus 3, which is equal to 4 neutrons. And lithium 8, we're going to do 8 minus 3, which is equal to 5 neutrons. So in this example, determine the number of neutrons in each isotope. So for uranium-238, we would do 238 minus 92, which is equal to 146 neutrons. Krypton-84, we're going to do 84 minus 36, which is equal to 48 neutrons. Chlorine-35, we're going to do 35 minus 17, which is equal to 18 neutrons. And then carbon-14, we're going to do 14 minus 6, which is 8 neutrons.